Welcome everyone. Welcome to today's Pension, Retirement and Aging Seminar. Before we begin the proceedings, I'd like to acknowledge the traditional owners and custodians of country throughout Australia and their continuing connection to land, waters, and culture. We pay our respect to the elders past, the present, and emerging, and extend that respect to Aboriginal and Torres Strait Islanders who are present here today. So today, I'm very pleased to say that we have Dr. Jane Fry to join us to share her research work. Dr. Jane Fry is a postdoc research fellow in the Demography and Aging Unit at the University of Melbourne Nod of CEPAR, and then an adjunct senior research fellow at the Curtin University of Population Health. Having spent 14 years as a government economist with the Productivity Commission, she undertook her PhD in health economics at Monash University and completed it in 2020. Her primary research interest is in quantitative modeling applied to various economic issues affecting older people. She has investigated how labor market conditions affect older Australians during the COVID-19, energy poverty among retirees, retirement and well-being, the heat-eat trade-off among low-income individuals in Australia, and health literacy and food insecurity among older people. She's also providing input parameters and data to an individual level microsimulation model of the Australian population that will be used to project the Australian population according to various characteristics, such as age, sex, country of birth, English proficiency, education, and labor force participation. So today, Jane is going to share her research work looking into energy poverty amongst the older people, which I think is a very interesting topic. And also previously, we are kind of lacking this type of topic at this seminar series. So it will be a great topic and also very interesting piece of work for Jane to share. And thank you very much, Jane, for joining this seminar and sharing your research work.
Well, thank you for that very warm welcome and introduction. It's lovely to be here. This is a piece of work that has now actually been published. We'll have a go looking at retirement income sources and energy poverty. So the first thing I need to do is to give the standard acknowledgement. We're using unit record data from the HILDA survey, which is Household Income and Labour Dynamics in Australia. The HILDA project was initiated and funded by the Australian Government Department of Social Services and is managed by the Melbourne Institute of Applied Economic and Social Research. The findings and views reported here, however, should not be attributed to either DSS or the Melbourne Institute. And I've given the reference there. The paper's been published in Energy Economics, and both myself and Jeremy are funded by the Australian Research Council's Centre of Excellence in Population Ageing Research. Okay, so I thought I could give you a little bit of background about energy poverty, as it's something that you may not know a great deal about. There is no standard definition, but I've put up here one definition of energy poverty is a situation in which a household lacks a socially and materially necessitated level of energy services in the home. So those energy services, the needs include heating, cooling, lighting, refrigeration, cooking technology, and use of medical services and the like. The concept itself dates back to the 1970s and has been the subject of over 500 studies. So it's actually an up and coming thing still. Energy poverty has been recognised as a global problem and is encompassed in the Sustainable Development Goals, particularly number 7, which is about ensuring access to affordable, reliable, sustainable and modern energy for all. So rather than access to energy, which is typical of studies in developing countries, we're going to focus on the affordability issue, as access is not such a problem in developed countries. Okay, now we'll run through some of the energy poverty measures. Now, there are many, many approaches to measurement. The first one is looking at consumption relative to minimum energy requirements. for basic necessities of life. Now, the problem with that measure is that we don't really know what those requirements are. And even where we have some idea about information relating to housing conditions, we do have troubles getting detailed data on a large scale. So there's problems with that sort of idea. There are also objective measures. The typical one that's been used historically has been a 10% or more budget share, which speaks to the idea of a poverty line. Another one is looking at twice median energy spending, given that they think that that's roughly where you should be if you're not in energy poverty. There's a minimum income standard, which is like a threshold for having sufficient warmth and energy. There's after fuel cost poverty, which again is like an income threshold. And more recently, there's what's called the low income high cost measure, which is where you have energy costs above the population median and income below the poverty line at the same time. But the problem with that is that you can have adaptive behaviours which can affect expenditures. So therefore you have people that may well be in energy poverty, but the objective budget measures don't capture that. Okay, so then we have subjective measures, which are things like being unable to heat your home, having damp conditions, and being unable to pay bills on time. Now, these measures get at the lived experience, but the problem is that they're still open to interpretation and can be difficult to collect data on. And the first two that I've put there don't actually take account of cooling expenses, which is quite important in a country like Australia. And there are also composite indicators which combine things like indicators of the 10% budget share, being unable to heat, and low income, high cost. So that's where you're combining several into one. Okay, so in terms of the effects of energy poverty, well, energy poverty has been linked to lower subjective well-being, poor self-assessed health, circulatory diseases, respiratory problems, poor mental health, and in the extreme, mortality. So that's something that in the cold climate countries is a big issue, where they talk about excess mortality. And all of those can have flow-on effects to the healthcare sector. So that's why it's a concern. Now, in addition to the health problems, there may also be stigma associated with things like disconnections, and those sorts of things could lead to what's called a heat or eat trade-off. And that's where people don't have enough money to go around to service all their needs. So they start trading off using heating their homes in preference to having enough food to eat. And that's the subject of another paper that I've been working on. So energy poverty is a particular problem for retired people, as many of them have fixed and often relatively low incomes, and they're often based on superannuation or government pensions. And that's going to cause additional financial pressure if retirees have underlying health conditions that increase their energy requirements. And it may well be that because they're less active than the younger population, that they need increased thermal requirements. Okay, so what's the significance of energy poverty? Well, it's topical among older people in Australia because energy poverty has been exacerbated by the COVID lockdowns that we had in Australia. And that meant more time at home, which meant that the aged pensioners had up to 50% higher energy bills in 2020 than in 2019. It's also the case that energy poverty is becoming more likely with climate change. So that's something else that we have to consider. Now, most studies on energy poverty focus on heating in cold climates. So, for example, across the northern states of the US and Canada, and through the northern parts of Europe and the UK. But there's also a growing literature relating to energy poverty in Australia, which we regard as being a warmer climate country across the whole nation. Now, the problem is that extreme heat can lead to problems cooling houses, and that can have adverse health implications that can be just as bad as not being able to heat your home in the winter. And estimates of energy poverty in Australia range from about 2% to about 12%, depending on the measure, and that's based on several Australian studies. So now we need to think about retiree income, which is probably something that most people in the audience are more familiar with for Australia. So briefly, based on the 3 pillars of retirement income, according to their income source, retirees can be categorised as age pensioners who are fully funded by the public transfers, part pensioners whose age pension rates are reduced due to a means test, or fully self-funded retirees. And they're usually funded through superannuation, but there can also be other investments that they draw income from. Now, income sources may affect energy poverty through differences in income levels and other less direct channels. So, for example, even with the same income, age pensioners could do better than self-funded retirees because they're entitled to additional government-funded benefits such as energy supplements, which are already included with the age pension payments. And part pensioners are likely to be in the middle as they've got some private income and they receive some concessions that the self-funded retirees don't. And the Commonwealth Treasury is expecting the proportion of self-funded retirees to stay about the same, but the split between the pensioners and the part pensioners is going to move towards part pensions as the average superannuation balances increase, and that's due to higher rates of contributions over longer periods. So we're seeing the end of the baby boomers who were caught in the middle between the entitlement to an age pension and having enough superannuation over their lifetimes. Okay, so here's a little bit of information about energy prices and pensions historically. I've put in since 2000 because that's roughly when the HILDA survey started. And you can see these are at the national level. So you can see there's been a trebling of electricity and gas prices over our sample period. And most of the action's been in energy prices post-GFC, so since about 2008. Now, I've put in there the standard and partnered pension rates, and you can see that they've been falling behind the energy prices over that period. Now, self-funding arrangements are really difficult to include because you've got to consider whether you're talking about total balances or income that's drawn, and that's going to vary by age over time, whereas the pension and the prices are the same for everybody. So I found very limited data on superannuation balances at age 65 or over, but it's not really enough to use. So later on, if there's anybody who's got suggestions about where I might get some usable data on that I can add to this picture, that would be really useful. So we're using waves 5 to 19. We have a sample of retirees that are identified as being age 65 or over and no longer working at all. I'll talk a little bit more about that in a minute. But we also collect annual household expenditure on energy, which includes electricity, gas, and other heating fuel bills. And our subjective measures of energy poverty are considered to be due to a shortage of money. So they're actually related to finances. And for some reason, best known to somebody else, they didn't collect that information in 2010. So we had a slightly different sample period. And our sample size is between 3,600 and 3,900 respondents over the period, giving us 20 to 24,000 observations because the individuals are only in about 5 to 6 waves on average. And that depends on the measure of energy poverty because we have some item non-response to the subjective measures which are in the self-completion questionnaire. Okay, so here's just an overview of the retiree types that we have. We start off with our full pensioners and we say that, well, actually across all the groups, that we're ruling out having wages and salaries or business income because we're saying that they're actually retired and they're not working at all. For full pensioners, we also exclude investment income, private pensions and regular private transfers, and foreign pensioners and irregular income. So their only source of income is the age pension and potentially other Australian government income support and non-income support payments and allowances. The self-funded retirees, we're ruling out the age pension and those other government supports. And we're saying that they can have investment income, private pensions or regular private transfers and foreign pensions and irregular income. And then we've got the part pensioners who, again, we say have no wage and salary or business income, but they can have a mix of these other three income sources. And in doing this, we're abstracting from full pensioners who are working limited hours because that's going to change their energy requirements. Okay, so the energy poverty measures in HILDA. We start off with an objective measure of low income, high cost, which is a binary indicator. And that looks at equivalised disposable income less energy expenditure being below the poverty line, which is 60% of the median income. And at the same time, they have equivalised energy expenditure above the population median. Our next measure is subjective, and that is being unable to heat the home due to a shortage of money. And again, that's a binary variable. And that applies to the period since January, which is specifically asked. And you should keep in mind that most people are interviewed between August and December. So that's going to really relate to, in particular, the most recent winter. And they're two of the most common measures in the literature, so we do use those. But there are some other ones that get used, which we've also experimented with. One is objective budget share, which is an annual measure. So that's what proportion of their budget gets spent on energy. Another objective measure is an indicator of whether the budget share is greater than or equal to 10%, which is the 10% budget line we talked about earlier. And again, that's based on annual information. And then we have another subjective measure, which is about being unable to pay your electricity, gas or phone bills on time due to a shortage of money. And again, that's asked since January. And again, most people are interviewed between August and December. So we should note that measure 2, being unable to heat, is not going to capture energy poverty due to cooling costs.
Sorry, Jane.
Yep.
We have a question from Anthony. He says, but full pensioners can still have assets outside the home of more than 10 times an annual pension.
Something that, again, we would have to go to the wealth module in HILDA to be able to identify. So our data is not the best for this purpose, but it's the best available that we could get. So we're going to look at both objective and subjective measures because there might be adaptive strategies at the intensive margin. Now, some of the forms of energy poverty can be reduced by coping strategies rather than simply going without. So overall, it might be that you reduce your use of lighting or you're eating uncooked foods. In colder weather, you might be using gas fires rather than central heating, heating only one room, avoiding hot water use, wearing more clothes, using blankets or going to bed early. During the hot weather, you might be doing things like opening windows or visiting air-conditioned shopping centres or public libraries to avoid the heat. Now, the adaptive strategies can lead to differences between the objective and subjective measures of energy poverty. But the subjective measures get at what we call lived experience. Okay, so our empirical strategy, briefly, we're going to estimate fixed effect and random effect models for our main energy poverty measures and again for our alternative energy poverty measures. Now, we might consider that retirement income source is endogenous, so we're going to estimate a Lubel IV to account for endogeneity and have a look at the results. Then we're going to think about some potential channels that might be linking energy poverty and retiree type. And finally, we'll think about the influence of omitted variables. Okay, so here is our basic model of energy poverty. We start off that we include retiree type, which is our full pensioner, part pensioner, or self-funded retiree, and we're going to keep part pensioners as the reference group. We then have individual, state and time fixed effects in the model, and we have our X variables, which are comprising age, sex, marital status, education, income, all those sorts of usual things. Now, ideally, we want to use fixed effects to model for unobserved heterogeneity, but individuals are only on average in about 5 to 6 of the 14 waves. So we're going to also estimate a random effects model. And you should note that with the fixed effects model, retiree type is actually changing for some people over time. So it's actually not wiped out by the fixed effects. Okay, so here's some descriptive stats on just the main variables of energy poverty and retiree type. We can see there's much higher low income, high cost related to the low incomes of retirees and their high energy costs relative to the Australian population. So if we looked at another study that's included the whole population, low income, high cost is at about 5%, whereas for us it's about 20%. We've got also, compared to other studies, a higher budget share than other papers because we've got retirees with lower household incomes, and there are also fewer income earners in the household. Our proportion with 10% indicator is roughly within the ranges that we've seen elsewhere, usually between 2 and 10%. We've got 5.8%. Being unable to pay is smaller than in other studies, and we think that's because older persons are prioritising paying bills. So it might be that there's an energy food trade-off in there. Interestingly, unable to pay bills is much higher than being unable to heat, and that suggests that they have lower heating requirements or there's more adaptive behaviours. But at the same time, we have to consider that bills also includes phone bills. So it's a bit broader measure. Okay, here's some descriptive stats on the other variables in the model. One of the key things is the age. The average age is about 75 years, ranging from 65 to 101. Our income measure, the mean is equivalent to about $32,000. But it ranges from $204, which is where individuals appear to be living on cash assets rather than income as such, and it ranges up to 1.6 million. Disability is also quite high, and that relates to having any long-term condition, impairment or disability that restricts everyday activities and has lasted or is likely to last 6 months or more. So that's going to include things like sight problems, hearing problems, limited mobility, mental illness, effects of head injuries and strokes, arthritis, asthma, heart disease, Alzheimer's, dementia, and so on, which are much likely to be higher in our older population. Okay, so here's our main results for our main energy poverty measures. I've just restricted attention to our main variable of interest, which is the retiree type. Our fixed effects aren't as precisely estimated as the random effects. So for energy poverty 2, which is unable to heat, we're finding that the effect is not significant. But we do find that we're getting consistent signs on energy poverty by type. Now, with unable to heat, the fixed effect on retiree type's not significant, which suggests that when we compare with the random effects model, maybe there's some unobserved time invariant effects that are removing the effect of retiree type, but we're not really sure about that. So what we see is age pensioners have more energy poverty than part pensioners, and self-funded retirees have less. Now, this model's controlling for income levels, so maybe the difference is about things like lack of family support for pensioners in hard times, which relates to social isolation or living off assets. And the difference between the two energy poverty measures might be due to cooling that's included in low income, high cost, but not in the unable to heat measure. Okay, so here are our three other measures. Energy poverty 3 is the budget share, 4 is the 10% indicator, and 5 is the unable to pay bills. So with the shares, unlike earlier, here self-funded retirees are considered to have more energy poverty and age pensioners less. Now that might be because energy supplements are available to pensioners but not self-funded retirees, and also that age pensioners just make do with less and self-funded retirees are choosing to spend more. Unable to pay bills is similar to unable to heat in terms of the age pensioners being most disadvantaged. But it might be that there's something around attitude to debt or paying bills that might be a fixed effect that's wiping out our age pensioner / self-funded retiree effect. Okay, so then we think about endogeneity of retiree type. And what we could think about is that energy costs while you're in the labour force could affect voluntary superannuation contributions, but external survey evidence indicates only about 20% of people are making regular contributions, and they're not as likely to be in this older group. Employer superannuation contributions are a fixed % of salary, so they vary by occupation. But for most people, occupational choice is going to happen when individuals are young and not responsible for paying the energy bills. There might also be something around the timing of retirement, but most retirement decisions are due to reaching the age for eligibility of access to private or state funds. But nevertheless, we're going to estimate a Lubel IV with internal and external instruments. And the external instruments are the state wage index and the state population age 65 plus. Okay, so here are our results. In this case, we have to note that because of the way the estimation is set up, this has to be done with the fixed effects estimation. We have two instruments, which are the state wage index, and that determines the relative trade-off between remaining in the workforce and retiring. And we also have the state level variation in the population aged 65 and over, and the size of that cohort is going to impact labour force opportunities. Now, we should note that the Boyce-Pagan test is significant, so we have heteroscedasticity in our model, which we need for being able to rely on internal instruments that this technique uses. Now, I haven't shown it here, but the external instruments are actually quite weak because they have an F statistic less than 10. But there's no significance on the endogeneity test. So that looks like we're okay and that we've actually estimated causal effects. So again, we're seeing that the pensioners have more energy poverty on the low income, high cost, and the self-funded retirees less, but there's no difference in unable to heat. Now, we also briefly investigated disability and the effects on energy poverty, but we found no significant evidence of endogeneity. So here's where we start thinking about the mechanisms that might be important. So we investigated to the extent that we could wealth and assets and social isolation and general health as being potential channels that link retiree type to energy poverty. So in the first step, we found that pensioners were significantly less wealthy and had less assets and worse health and more social isolation than part pensioners. And self-funded retirees had significantly more wealth and assets, better health and less social isolation than part pensioners. So the next part of the channel analysis is to model with and without the channel variable. So an effective channel is indicated by a significant coefficient on the channel variable and smaller coefficients on retiree type when the channel variable is included. So what we found is that net wealth, assets and social isolation and health were all mechanisms for unable to heat, but not for low income, high cost. So low income, high cost is actually income based, and it's liquidity rather than assets and wealth that matters. So that's why we might expect that answer. But wealth and assets sort of form a psychological buffer against a perceived inability to afford heating. So that might be why we're seeing that result there for the subjective measure. Isolation impacts a perceived ability to afford heating. So it might be that you have no support networks, you're unwilling to heat your house when nobody else is at home. And that's rather than an actual inability to afford heating. And there might be different health outcomes for retiree types due to healthcare costs, which lead to different energy needs. Okay, so then what we wanted to do was to investigate the effect of omitted variables. And for this, what we do is conduct Oster's bounds analysis. Now, what I've done here is to put all the results for the two main models, but it's really only the first one where we've got significant estimates that we're going to investigate in any detail. So basically what we're doing is looking at the extent of bias using the stability of coefficients when we include the covariates to indicate limited influence of omitted variables. We then estimate consistent bounds on the estimates, and they're what we would have obtained if we'd included all the unobservables in the models, and they're based on the hypothetical model. And then we look at the relative impact of observed to unobserved covariates to see the influence. Now, this is a standard way of reporting results. So we have the baseline effect that has no other covariates in the model, the control effect, which is the set of results that we presented earlier. Then we have the consistent bounds that we include, and we estimate the effect of the relative contribution of unobservables. So in this, there's two things that we really need to note, which I've put in red there. One is that these bounds here exclude 0 in both cases. So hence we've got the yes here. And this thing here, delta, indicates how important the unobservables would have to be relative to the observables for the effective retiree type to go to 0. So a value of 1 says that they're equally important. So you can see for self-funded retirees, we're going to a delta of 0.86. And that's saying that there's potentially some important omitted variables, but at the same time, the coefficient or the controlled effect is not actually significant anyway. So it's not like we're going to include unobserved variables and suddenly the coefficient is going to become significant. That's just not going to happen. But we can see for pensioners, the low income, high cost is showing the effects of unobservables would have to be nearly 5 times greater than the effect of observables for our coefficient to go to 0. So what we're actually saying there is that's going to be extremely unlikely. So omitted variables aren't a concern for the pensioners there. Okay, so in summary, here are our significant effects that we had. And these are based on the random effects results. So we have pensioners having more energy poverty on the low income, high cost and the unable to heat measures. There's less energy poverty on the 2 budget share measures. And there's more energy poverty in response to being unable to pay bills. And for self-funded retirees, we're finding the opposite. Now, in thinking about the low income, high cost versus the budget measures, Part pensioners are more likely to bear high costs, but they're not necessarily in the low income bracket. So therefore, pensioners are spending less of their budget there. And we should note that with low income, high cost, it's equivalised disposable income, less energy expenditure being below the poverty line, and at the same time, equivalised energy expenditure being above the population median. What we find is there was no evidence of endogeneity. We have those apparent channels being wealth, assets, health, and social isolation. And omitted variables are unlikely to be a problem for our estimates. But as we said earlier, the problem with the wealth and assets is we're only getting measures every 4 years. So I'm not sure that's enough to be able to really identify what's going on there. Okay, so thinking about energy poverty, what are the solutions to this? Well, we have short-term and long-term solutions. The short-term are often regarded as palliative. And they're things like increasing income through price regulation. So that's things like social tariffs and prepayment meters. But there's also some evidence coming out of New Zealand and several other places that prepayment meters actually make energy poverty worse, because often, although you're paying at the point where you're using the energy, the prices are actually higher. So they allow you to budget, but over the long term, they're going to increase the amount that you're actually spending. There's also direct financial support through bill reductions, payment plans, and targeted financial transfers. And there's the idea of trying to avoid disconnections or allow minimum energy supply during extreme temperatures. And that's usually through having minimum arrears prior to disconnection. So that's about allowing people to manage the additional expenditure that's required when the weather is extremely hot or extremely cold and their needs go up. And then there are the longer term, which we consider curative or preventative measures. And they're things like improvements in energy efficiency, and that can be in appliances or the dwellings. And that's perhaps through subsidies for new purchases or installations and retrofitting. But the problem with that is that it can require consumer training, in particular for landlords to retrofit energy saving measures into tenanted buildings. There's not necessarily the right incentives for them to do that, and they don't necessarily understand about the benefits in doing that. So we've got some of these, but maybe we don't have enough that's specifically targeted to age pensioners. So maybe we need to think a bit further about that. Okay, so in conclusion, we found that not all retirees have the same probability of experiencing energy poverty, and the means of funding retirement is critical to energy poverty outcomes. It's important that retirees' health and well-being is not impacted by an inability to heat or cool their homes. And that's really important because we were talking earlier about those adverse health impacts, both of heating, of extreme heat and extreme cold. Age pensioners are also the most likely to be at risk of experiencing energy poverty, and it might be that targeted policy could be used to address this issue. So that age pensioners are faring the worst is maybe not surprising, given the growth in energy prices has been much faster than the growth in the age pension in Australia. So maybe we need to think a little bit more about that. Tackling energy poverty can also involve concessions to energy bills or funding for targeted energy efficiency upgrades. And as we said, prepayments used in some places, but there's some evidence that it actually makes energy poverty worse. And finally, government-funded pensions are supposed to act as a safety net, but they need to remain sufficient in times of increasing energy prices. And that's particularly been relevant since COVID, where we've had the prices going up so much more and the more time spent at home. Further attention needs to be paid to the gap between state-funded and self-funded retirees in order to ensure equity in older populations. Thank you.
Thank you. Thank you, Jen, for sharing the very interesting topic and the very interesting work.